Hello, students, and a very good morning to you. Students, today we are going to start Chapter 14 of Class 7 Science, that is, Electric Current and its Effect. And this is the first part of this chapter. Now, let's have a look what we are going to study in this video. So, first of all, we will have some general introduction about electric current or electricity, because about electric current or electricity we have studied in 6th class also. So we will have first we will have general introduction about electricity, then we will see what is electric circuit, then symbols of electric components, open and closed circuits, and then type of circuits, in which we will study about series circuits and parallel circuits. So students, in class 6th we have studied about electric current, we have studied about electric circuits also. So first of all, in 6th class we have studied about how electric current is generated, means how electric current is produced and how it is important to us, because we know that we cannot imagine life, we cannot imagine world without electricity. We need electricity at homes, in offices, in industries, in factories, means everywhere. Electricity is used at home for lighting, for operating fans, for heating purposes. In industry, electricity is used to run different type of machines, and in transport sector, electricity is used to pull electric trains. Then a number of electrical appliances such as electric kettle, toaster, heater, air conditioners, oven, etc., they work because electricity flows in them. So in this chapter, first we will see what is electricity, means what is electric current, then we will study about electric circuits also, and then we will study about types of circuits, then means series circuit and parallel circuits. And after that, in this chapter we will study about the effects of electric current, in which we will study about heating effect and magnetic effect. So these two effects we will study in this class only. In our next videos, and two more effects are there, that is chemical effect and mechanical effect. So these two effects we will study in higher classes. So first of all, we should understand what is electricity. Okay, means our first question should be, what is the charge, means how the charge is generated, how the electric current is generated. So students, we know that all the substances in the world, they are made up of atom. Okay, atom is the smallest unit of matter, and it is electrically neutral, means first of all, atom is not having any charge, and this atom consists of some charged protons, but electrically it is neutral, but it consists of some charged particles, that is positively charged particles, negatively charged particles, and neutral particles. So suppose we are talking about atom of any substance. So what is the structure of atom? In atom, there is a central circular structure. This central structure is called, which is present in the center, this is called nucleus, and this nucleus is surrounded by so many shells or orbits. Okay, now suppose this is the atom of any substance. So this central circular structure is called nucleus. Okay, and this nucleus is surrounded by many shells and orbits. So these are the shells or orbits. Now atom, basically the atoms, they are having three type of particles: positively charged particles, negatively charged particles, and neutral particles. So positively charged particles are called protons, they are having positive charge. Then negatively charged particles are called electrons, they are having negative charge. And some neutral particles are there, means they are not having positive charge or negative charge. So these neutral particles are called neutrons, they are having zero charge. Zero charge means neither positive nor negative. So these two particles, neutrons and protons. Protons means positively charged particles and neutrons means negatively charged particles. These two particles collectively they are called nucleons, and they are present in the nucleus of the atom. Okay, means in the center part of the atom, means in the nucleus of the atom, neutrons and protons are present. Protons, they are positively charged, neutrons, they are neutral. Okay, so these two particles are present in the nucleus of the atom. Now electrons, they are negatively charged, and they are present in the shells or orbits of the atom. So generally the number of protons and number of electrons, they are equal in any atom. That is why atom does not carry any charge. That's why I have told you that atom is electrically neutral. Why? Because number of electrons means number of negatively charged particles, and number of protons, that is number of positively charged particles, these two particles, they are equal in number. That is why atom does not carry any charge. But in some special conditions, these materials, they tend to release electrons because they can release electrons only because electrons are present in the outer orbits or shells. Okay, and electrons, they are having very light weight. That is why they can move, they can jump from their lower classes to higher classes. Okay, so electrons can move. So generally the number of electrons and protons, they are equal. That is why atom does not carry any charge. But in some conditions, these materials, they can release their electrons, means they are negatively charged particles. And when any atom releases electrons or negatively charged particles, then it becomes rich in positive charge. Suppose in in any atom 10 electrons and 10 protons are there. Suppose that atom releases one electron, so obviously number of electrons will be 9 and number of proton will remain 10. So obviously this atom will become positively charged. Okay, so in some conditions, when any material releases its electrons or negatively charged particles, then that atom become rich in positive charges, and the other atom which receive this electron, that atom will become negatively charged. Okay, so just because of this imbalance of charges, a body, it turns into a charged particle or charged body. Now come to the topic, that is what is electric current. So electricity is the movement of charges through a body. Charges means obviously negatively charged particles, because all of you knowing that only electrons can move, protons and neutrons cannot move because they are present in the nucleus of the atom. So obviously electrons can move. So when negatively charged particles, means electrons, they flow, they produce electric current. Okay, so here you can see this is a cell, and this is the positive terminal and this is the negative terminal of the cell. That much you have studied in 6th class, that is why I'm explaining you here. So all you know that this is, if this is a cell, this is the positively charged terminal and this is the negative terminal. Okay, so electrons, they are negatively charged particle. It means they will be attracted towards positively charged particle or positive side. Okay, so this is negative terminal, so obviously electrons are also negative, so electrons will move from negative side to positive side, means electron will move from negative terminal to positive terminal. When electrons start moving from negative terminal to positive terminal, then one energy, that is electrical energy, will start moving in the opposite direction. That is why we can say that electricity is just the movement of charges through a body, and the flow of electric charges, that is the electron, the flow of electric charges, that is electron, is called electric current. So this is a simple circuit where electrons are moving from negative terminal to positive terminal. In that time when electrons are moving from negative to positive terminal, one electrical energy, it will start moving in the opposite direction, in the direction of flow of electrons, that is positive to negative terminal, and this electrical energy itself is electric current. So electricity is the movement of charges through a body, and the flow of charges means the flow of electrons is called electric current. Now, the direction of the flow of electric current is from the positive to the negative side, means electrons will move from negative to positive side. So obviously the direction of the flow of electric current will be opposite to the direction of flow of electrons, that is electric current will move from positive to negative direction. Now, ammeter is used to measure the electric current in a conductor, means if we have to measure the amount of electric current, then one instrument used, that instrument is called ammeter. Ammeter is used to measure the electric current in a conductor. Now the SI unit of current is ampere. So ampere, it is the SI unit of electric current. Now we will see what is simple electric circuit, because electric circuit we have studied in 6th class also. So I hope you all are familiar with electric circuit. So electric circuit is a complete pathway for the flow of electric current, means we are knowing that this is a simple electric circuit, because in this simple electric circuit we have studied about simple electric circuit. So this is a complete pathway. Complete pathway means this pathway is not broken anywhere. This is a complete pathway. So through this complete pathway electric current can flow. So the complete pathway through which electric current can flow is called electric circuit. Okay, now an electric circuit usually it consists of four main components, that is source of electric current, that is cell, one appliance or electric device, means it should be heater, bulb or any other electric device, then conducting wire, and switches to complete and break the circuit. So here you can see this is the diagram of simple electric circuit. So this is the cell, or we can say battery, which is the source of electric current, means it provides the electrical energy, means it provides the electric current in the electric circuit. Then this is the bulb. So bulb is the electric device on which will work on electric current. When electric current flow in it, then the bulb will light up, or in the place of bulb, we can take the example of any other device also. We can take the example of heater or fridge or fan, anything else. Then conducting wires. So these wires are the conducting wires. You have studied about conducting wires also, because conducting wire can conduct electricity through them. These are made up of metals. You have studied that the copper wire is used as a conducting wire. We have also studied this in sixth class, that metal wires are the conducting wires because they can conduct electricity, and from outside they are covered with rubber or plastic, because rubber or plastic are insulator which protect us from electric shock. And switches to complete and break the circuit. So this is the switch, which when we will on the switch, then circuit will be completed and electric current will flow and bulb will glow or any device will work. When we will off the switch, then the circuit will be broken, and in that time the electric current will not flow and this bulb will not glow or any other device will not work. So electric circuit is a complete pathway for the flow of electric current, or we can say a complete pathway or unbroken pathway through which electric current can flow. That circuit is called, or complete pathway is called, electric circuit. Okay, electric circuit, it is having four components. So many other components are also there which you will study later on, but there are four main components. That is source of electric current, that is cell or battery. Then any one appliance, means any device, electrical device. Then conducting wire through which electric current can flow. And switches are just keys to make or break the circuit. Now, symbols of electric component. So here you can see some components and their symbols. So this is, first one is the cell. This is the source of current, we all know. So here this is the symbol of cell. So the longer line, it denotes the positive terminal, and the shorter and thicker line denotes the negative terminal. So if this type of symbol you are seeing in any circuit diagram, it means this symbol represents the cell in the circuit, where longer and thinner line represents the positive terminal, and this one, the thicker and smaller line, shorter line, it denotes the negative terminal. Now battery, this is also the source of current. So here this is the symbol of battery. So we all know two or more cells, they form the battery. So this is a symbol of battery. Now this is key or switch. So key or switch means if the switch is off, then it is called open condition, and if the switch is on, then it is called as closed switch. So these two are the symbols of open switch and closed switch. Then bulb. So these are the bulbs. This is the on bulb and this is the off bulb. So these are the symbols of the bulb. Now connecting wires. So connecting wires means through which electric current can flow. So these type of symbols you can see in any circuit diagram. So first one represents a single connecting metal wire. Then next one, two wires crossing without connecting each other, means if two wires are crossing each other but they are not connected to each other, then this type of symbol is used. And this symbol represents wire which are joined together, means the wires which are connected together. So first we will see electric cell. Electric cell, we all know the symbol of electric cell. It has two parallel lines. The longer line represents the positive terminal. Longer line represents the positive, and the thicker, shorter line, it represents the negative terminal. So all we know that cell is the source of electrical energy or current in any circuit. Means if any circuit is there, any electric circuit is there, so the main source of electric energy or electric current or electricity is electric cell. Now battery. So battery is a combination of two or more electric cells, we all know. And this is the battery. You can see this is also a type of battery. So students, we have in sixth class we have studied how to join cells together to make battery. So we know that it is formed when the cells are placed in such a way that the positive terminal of one cell is connected to the negative terminal of next cell. So here you can see, suppose this is the positive terminal, so and this is the negative terminal. So positive terminal of one cell is connected to the negative terminal of other cell. Here also you can see this is the battery of two cells, this is the battery of four cells. So this is the way in which the cells are joined together. Okay, now here you can see this is the negative terminal and this one is the positive terminal. So negative terminal of one battery is joined to the positive terminal of another battery. Here also, so this is the symbol of battery. Okay, so suppose only that much is present, that only two parallel lines are there, and parallel line represent the positive terminal and shorter thicker line represents the negative terminal, then it will be cell. But if some cells are there in a series, then it is battery, and battery is also the source of electrical energy. So battery, we all know battery are used in torch or transistors or toys or remote controls and so many other places also. Now, electric bulb. So electric bulb is an element in the form of coil, and you can see these two are the symbols of electric bulb. So first one is representing the off bulb, and second one it is representing the bulb is glowing here, so this is the on bulb. Now switch. Switch is a key which is used to make or break an electric circuit. Means when we will off the switch, then circuit will be incomplete, circuit will be broken, and when the switch is on, then circuit will be completed, circuit will be closed circuit. So if the circuit switch is off, as you can see here, if the switch is off, in that condition circuit will be incomplete circuit or open circuit. And these are the symbols, these two symbols generally they are used as to denote the switch in off condition or circuit in the open condition. So this is symbol is also used and this symbol is also used. So these two are the symbols of off switch. Okay, and these two are the symbols of on switch. Means if in a circuit diagram you are seeing such type of switches, such type of symbols of switches, it means the circuit is completed. So the circuit having this type of switches, then the circuit will be incomplete or open circuit. It means electric current will not flow in that type of circuit. And if in any circuit you are seeing such type of switches, it means that circuit is in closed circuit, switch is in on condition, and electric current is flowing in that type of circuits. And these switches also they are made up of insulating materials as bakelite, because the insulating materials, these bakelite type of materials, they are insulators. So this is all about switches. Now connecting wires. So connecting wires are used to connect the various components in a circuit, and they are represented by lines. So here you can see this is a simple line, this is the simple wire. This symbol represents the two wires crossing each other but they are not connected to each other, and this is representing two wires which are connected to each other. So this is all about the components and their symbols which are used in any electric circuit. Now two more components are there which are used in any electric circuit. So first one is galvanometer. So first one is galvanometer. Galvanometer is used to detect the flow of current in any circuit. Means when we have to detect the flow of current, then it can be detected by galvanometer. And voltameter is used to know the voltage, means it is used to know the potential difference or voltage in any electric circuit. So this voltameter, it is in any electric circuit, it is represented as V. Now, next topics are resistance, conductors, and insulators. So, about conductors and insulators, we have studied in sixth class also that the materials are substances through which electric current can flow. These materials are called conductors, and the materials through which electric current cannot flow, these materials are called insulators. Now, here we will study about the reason why some materials can conduct electricity and some materials cannot conduct electricity. So, the reason behind the property of the material of for conducting electricity or not conducting electricity, of being conductor or insulator, the reason behind that properties is resistance. Now we can say that some substances, they allow the flow of electric current with more ease than others. Suppose you are saying that silver is very good conductor, we all know. So suppose we are comparing silver is good conductor, then iron, or we can say iron is a good conductor while paper, rubber, plastic, these are bad conductors or insulators. So, why these things are insulators or bad conductors, or why iron or silver or gold or any other metal can conduct electricity? Means, if these are materials, so some properties they are having through which some materials can conduct electricity and other materials cannot conduct electricity. So these things are related to this topic, that is resistance. We all know that when current flows through any metal, electrons also move through them very easily. Means when electrons move, then only current will flow. We can say this. So when electrons move through any substance, they have to face some problems. These problems are in the form of hindrance or obstacle or hurdles. So they have to come across some imperfections within the material which cause opposition to the movement of electrons. Okay, so the hindrance in the path of moving electrons, suppose electrons are moving and now they are facing some problems or some hindrance or some obstacles or some hurdles, means these hurdles in the path of movement of electrons is is known as resistance applied by or offered by that particular substance. Suppose electrons are moving through plastic. So plastic have some property which will create some hindrance or obstacle or hurdle in the movement of electrons, means it will not allow the electrons to move through it. So this hindrance which is caused by that particular substance which does not allow electrons to move through them, this hindrance in the path of moving electrons is called resistance. So all materials including metals, they show some level of hindrance or some level of resistance or obstacle to the flow of current. So electrical resistance of a material is just a measure of its hindrance to the flow of electric current. Means what is the measure of hindrance or what is the measure of obstacle any material is having in just which is not allowing the electrons to move or electric current to move through that material, it is called electric resistance. Means electric resistance is of a material is a measure of its hindrance to the flow of electric current. Means how any material is not allowing electrons to move through this that material, it is electrical resistance. Now, the unit of electrical resistance is ohm, and this is the symbol of ohm. So students, the material, if it is having higher resistance, it means it can very lower amount of current it can pass. Means the higher the resistance of a material, the lower the current it can pass. So on the basis of their capacity to allow the passes of electric current, various materials are considered as conductors and insulators. So the substances like metals, they can conduct electricity well, and they are called good conductors, or simply they are called as conductors. So they offer very less resistance to the flow of electric current. Means these materials are having very small hindrance or very little hindrance or obstacle in the way of movement of electrons. Means they are offering very less resistance to the flow of electric current. Okay, so some materials, they are having very less resistance, as silver. That is why silver is the good conductor of electricity. Okay, but not all metals are good conductors. So this property of different resistance offered by different material towards the flow of electric current, it can be used in various applications of electricity that you will study later on in this chapter only. Now, the materials that show high resistance, they cannot conduct electricity, or they can, means they can conduct almost no electricity through them. So these materials are called insulators. Insulators means bad conductors of electricity. So we all know pure distilled water, it does not allow electric current to flow through it, but very small amount of if the salt or acids or alkali is added to it, then it can conduct electricity. So these are generally poor conductors, or poor conductors means bad conductors or insulators. So insulators are also having very importance in the making of different type of materials. So these insulators are important in making electric circuits, various appliances, or various components in the electric circuits. So electric switches are made of plastic or bakelite, which are insulating materials. Then electric wires, means which are used in the circuits, they are also covered with plastic or rubber. So these are the uses of insulators. Now one more thing, that is semiconductors. So conductors and conductors and insulators we have studied. Now semiconductors. What are semiconductors? Semiconductors are the materials that are insulators at low temperature. Means at generally at room temperature also, the materials which are insulators, but at moderate temperature, at high temperature, when we will heat them or they will become hot, then they will act as conductors. So simply the materials that are insulated at low temperature and become conductor at moderate or high temperature, that materials are called semiconductors. So these semiconductors, they are some devices are there which are made from semiconductor materials, as solar cells, transistors, microprocessors, ROM and RAMs, etc. These are made up of semiconductors. Now, open and closed circuits. So open and closed circuits, they are just based on the switches. Means if in any electric circuit, now we are knowing what is electric circuit, the complete pathway through which electric current can flow, that pathway is called electric current. So now we know what is open and now these circuits are maybe of two types, that is open and closed circuits. So the circuit in which electrical contact is broken, here you can see in the diagram also. Here, this is a cell, this is bulb, and these are the connecting wires. So here, this connecting wire is not attached or not joined to the other end or positive terminal of the cell. It means this is an open circuit. Okay, so if any circuit in which electrical contact is broken at any point or the switch is off, so here you can see this is a symbol of open switch we have studied now. So this is a open switch. Open switch means switch is in off condition. So if any circuit electrical contact is broken at any point or switch is in off condition, then the circuit is called open circuit. Why? Because the circuit is incomplete. Okay, so if the pathway is incomplete or the pathway is broken, then through which current cannot flow, and this type of circuit is called open circuit. Now the circuit in which electric current can flow from one terminal to other terminal, it means this pathway is not broken. This is a complete pathway through which electric current can flow, or we can say the circuit in which the switch is in closed condition, means the circuit is in on condition, switch is in on condition, then this type of circuit is called closed circuit. So open circuit means the circuit which is broken, the circuit which is incomplete, just because the electrical contact is broken at any point or the switch is in off condition. Okay, the switch is in off condition, then that type of circuit is called open circuit, and in that condition electric current will not flow. So any device which is attached or which is present in that open circuit, that device will not work. So here bulb is present, so bulb will not glow in that open circuit. While closed circuit is complete circuit, means unbroken path. So through that unbroken path electric current can flow and this bulb will glow, or if any other device will be there, so that device will work. Now one activity is there to study that bulb glows when the circuit is closed. So for this we need some materials, that is two cells, cell holder, bulb, switch and connecting wires. So what are the procedure? First of all, we have to take a cell holder and we have to place the two cells in the holder such that the positive terminal of one cell is connected to the negative terminal of next cell, as you can see in the diagrams. Okay, now connect the bulb, switch and connecting wire with the cell holder, as you can see in the image. Now we have to observe what happened when the switch is on or switch is off. So here this switch is the switch can be made by us, or we can use the simple switch which are used in the boards also. Now we will observe that the bulb, here you can see in first condition the switch is in off condition. Okay, so obviously when the switch is in off condition, then the bulb will not glow because the circuit is incomplete. So in that incomplete circuit or the broken path electric current cannot flow, so obviously the bulb will not glow here. So bulb will not glow when the switch is in off position, means when the circuit is open, in that condition electric current will not flow. While in this condition you can see the switch is in on condition. Switch is on. Switch is on means the circuit is complete or the circuit is unbroken. That is why electric current will flow through the conducting wires and here the bulb will glow. Okay, so if the circuit is open, then electric bulb will not glow, and if the circuit is closed, then the electric current will flow and electric bulb will glow. Now last topic of this part, that is types of circuit. So there are two types of circuit, that is series circuit and parallel circuit. So what is series circuit? When all the devices are connected using series connection, then this type of circuit is called as series circuit. So here you can see these two bulbs are there and they are present in serial connection. Okay, so when the devices are connected using series connection means they are present in serial manner, then this type of circuit is called as series circuit. Okay, so in a series circuit, same amount of electric current flow through the all components placed in it, and the series circuit, there is only one path for the current to take. So this simple series circuit, it is very simple to make, it is very simple to design, but one drawback is there: when one light goes off, then all will go out. Okay, so this is series circuit. Now next one is parallel circuit. So when all the devices are connected using parallel connections, here you can see these two devices, they are arranged in a parallel manner. So this type of circuit is referred to as parallel circuit. Okay, so parallel circuit is a closed circuit in which current divides. The current enters at one point, it divides in two or more paths as the connections are there. Okay, before recombining to complete the circuit. So in a parallel circuit, each device is placed in its own separate branch. So here you can see two bulbs are there. So they are arranged in parallel manner in two parallel branches. So suppose from one point current will enter, so current will divide in that branches, and after that again it will recombine. Okay, so this is series circuit in which devices are connected into serial manner or serial connection, and this is the parallel circuit where devices are connected in the parallel connections. So this is all about your first part. In next part we will study about the effects of electric current. Okay, do watch the video and it will be better. First read the chapter, then watch the video. Okay, thank you students.